Hello and welcome to video 3 of the Intro to SAS on AU Apps video series. In this final video, I'm going to show you how to run a correlation, run a simple ordinary least squared regression, or OLS, run a multiple OLS linear regression, and then export all those results out of AU Apps and onto your local machine. So it's clicking back over to SAS. Previously we ran some descriptive statistics, we coded some variables, ran t-test. So now what I'm going to do, just go ahead and we're just going to sort by. And I guess you have a bonus feature now too. I forgot that we had this in here. We're also going to run an ANOVA. So this has the 3 different groups in it, rather than just the 2. So if we run the ANOVA, we can say, okay, we can look at the different distributions of each one, our overall ANOVA table. We have our box plots to kind of see, okay, where the differences might be. And then the differences between them. Great. Here's also some code if you want to run a chi-square test, so comparing corruption caddic with whether or not they're considered free. And that is how you would run your chi-square test. So you have your frequency, your expected, and then your percent, your totals, and then probabilities one as well. And it is telling you that you have 20% data that's missing. Great. So what I do now is we're going to run a correlation. A correlation coefficient, sometimes called Pearson product moment, or Pearson's R, is a measure of association between 2 continuous variables. The sign indicates either it's a negative, it's an inverse, versus positive, which is directly proportional relationship. So a 0 would be a no relationship, a 1 is a perfect positive relationship, and a negative 1 is a perfect negative relationship. So what I'm going to do is we're going to look at the correlation between the log of GDPPC and our corruption index, both continuous. So I'm going to do that by using proc core, stating our data frame name, listing our 2 variables of interest, and then click on run. It's going to give us a 2x2 table. So we have our descriptive statistics. Now the diagonal ones, that's the correlation between the variable and itself. That's not really meaningful. Next we have the variable of corruption with our log GDPPC. Now the off diagonals, they're actually the same thing here too. They're mirror images. So based on this, we do have a statistically significant correlation. It is a positive 0.79, so it's a strong and positive one, and it's statistically significantly different from correlation of 0. So we would reject the null that there is no relationship. Now we're going to go ahead and show you different ways of running regression. First, we're going to start with a simple linear regression. So 1 predictor or independent variable and 1 outcome variable. We're going to plot the residual and the predicted as well from this. So using a proc reg, stay in the data file name, the model saying GDPPC regressed on corruption. We're applying the residual and the predicted values. Okay, so it just finished running it. So we have a whole lot of output here to look at. This is our analysis of variance. This is our overall omnibus regression test, our model. It was statistically significant. We were able to account for a statistically significant portion of variability. Specifically, roughly 80% of the variability of GDPPC could be accounted for by corruption. Now looking at our parameters, we have our intercept. That's when we know nothing else about it. What is our best guess at the starting value? And then we have our rise over run, or our slope. So for each unit increase in corruption, as we go from higher scores in corruption, so that's less and less corrupt, There's an increase of 4,761 of the GDPPC. We can look at different, so we have our residual. So of our predicted values, that looks pretty normal. We have our fitted line. So this is our regression line, our 95% confidence intervals, and our prediction limits. Now what we can do here too is, let's say we wanted to add another variable. We go ahead and add literacy. So now we actually have a multiple linear regression. R squared is now about 70%. We actually want to look at the adjusted R squared because that accounts for the inclusion of multiple predictors in your model. Our omnibus regression is statistically significant. Our intercept is a little bit not as extreme before because now we've included some more information in here. Corruption category, it's actually less of an increase, but when we know what the country's literacy rates, as we increase literacy, there's also an increase in GDPPC here too. So that'd be multiple regression. There's also things like you can run a robust regression. So if I go into here and I type where it says proc reg, I'm going to change that to robust. So now we're going to run a robust regression using robust standard errors. Okay, looks like I have an error message in there right now. For the robust reg, I'm going to go ahead and remove that. And we've actually been running it on GDPPC, so I'm going to go ahead and change this to log of GDPPC. Now we have a robust reg. So when we have the R and the P that saving that and plotting it, because of that, we weren't able to use the robust reg. So what I do is went ahead and remove that. So now we have our robust reg. We have our goodness of fit. And we get a little bit more information about our estimates here as well. So let's say you wanted to export this and save these results. Now you can't copy and paste with AU apps. So what I do is we're actually going to take our reg and we actually use the log. I'm going to go ahead and highlight and run this. It's going to take the output, and what we're doing is we're creating it using ODS RTF, and we're creating a Word document that's RTF, rich text formatting. We're saving it onto our Z drive. So I'm going to go ahead and run that. I'm going to wait for it to finish. Okay. So in the background, you might have just had a Word document open up. And this is actually the Word document. It timestamps everything and date stamps it. And it has all the information from our regression that we just ran. So I went ahead and that exported everything. Let's say that you wanted to store this as a PDF, the robust reg, with GDPPC regressed on corruption. You'd use ODS PDF, state the path direction and the file location. So I'm going to go ahead and run that. Oops, I was trying to open up a PDF in Word. That's not what I wanted. I'll circle back on that in a second. We can also, if you want to have it be in the HTML doc, you can also do that too. So now we have it as an HTML. And then finally, let's say you want to take the data set, you wanted to export it out of a SAS data file and onto a CSV file. You just use a proc export data file command, say what it was, and then what the out file is going to be. So we're going to save it as a CSV file. Now you might have noticed before when we did the Z drive or the Z for the PDF, we had 2 slashes here versus 1. It doesn't really matter. I'm going to go ahead and run this. And now I'm going to go ahead, I'm going to close down SAS entirely. Let me minimize that. Let me go ahead and get out of that. So this was the original files I was using before. And let me show you the files that I created on my local machine in this process. So we have, this is our data set that we had made when we imported. We created a new version of that data file in the process of the code. We have our Word document with our regression. We have a PDF. So if you open that one up,